Well, thanks everybody. It's great to be here. Though obviously wish we could all be gathering in person, but these are the times we live in. So with that being said, ROS-II is obviously an enduring theme over the last couple years. We've gotten together, but there's been a lot of activity and fits and starts in the industrial side for sure. But we're seeing greater progress. You're going to hear more, I'm sure, my counterparts in this particular session discuss as well, but we've been focusing on specific capabilities, but then also trying to make contributions to make ROS-II a little bit easier to navigate, both for new folks just entering ROS or those who have legacy applications dating back a number of years. But first, let's dispense with some of the introductory kind of things. So I'm sitting over here in the United States, in Southwest United States in San Antonio, Texas, located at the Southwest Research Institute. We've got a pretty good sized campus. There's an aerial view there. Multidisciplinary institute, not for profit. We're about 50-50 government, contracts, and commercial. And we do diverse things from deep sea submersible, sort of certification and testing, all the way out through managing space missions right here from our campus. So been around since the mid 40s and focusing on applied R&D. Here within our specific department, we do a lot of advanced system development. Usually it's sort of one-of-a-kind solutions. There's a number of examples here. These are sort of field deployed or near field deployed. In fact, I think almost all of these are field deployed. We're doing handling of compliant materials or having to execute processes on very varying surfaces and dynamic environments, or of course navigating or inspecting and traversing in very hazardous environments, all of which has led our group to get involved with ROS dating many years ago, and then seeking to kind of like understand if there was interest in developing open source capabilities for industry leveraging ROS, and hence the ROS Industrial Open Source Project. And of course, I don't have to necessarily with this audience define ROS, but typically when I run in my kind of legacy automation circles, they ask about ROS and how ROS Industrial is different. And largely right, we're just trying to extend ROS into industrial relevant applications and industrial relevant hardware and interfaces, and bring along some tools that are very useful to enable industrial applications. You may also know about the membership, but one thing, I'm not going to belabor that, but the point of a consortium, right, is to sort of provide direction. There's a lot of things we can do. What do we focus on? Here, based on the workshops that we host, interaction with our members, the phone calls I get very late at night, these are sort of the things that we hear about, and the data points that we collect drive our vision to focus on these 4 pillars, where we're trying to get to the point of a consistent quality, improved user experience, and of course, obviously, the intelligent capability. Obviously, in recent years, we've seen a lot of work going on in human interface and reaction. One of those being a real explosion in augmented reality interaction with robotic systems. A lot of focus on interoperability. There was an AMR standard that's been pushed out here in the States not long ago. And of course, you're going to hear more and more about the no-code revolution, which seeks about ease of use. These are all things that we hear about. And obviously, as we get into ROS-II, this comes up quite a bit as well, particularly for those navigating, hey, I'm still using ROS-I. How do I proceed in understanding both ROS-I and sunsetting and take advantage of advanced features of ROS-II, right? That's a whole new realm. The RMW component drives a lot of questions about ease of use. Relative to ROS-I and ROS-II, for those of you who've seen me talk, I always drop this in here. We're really working hard to make this vision a reality where we can. I will touch on a few capabilities right now that we have rolled out that are built exactly like this. So I encourage you to kind of test them and see if it works. But because we are industrial, if you've worked with legacy industrial providers, they offer backwards compatibility or support for sometimes upwards of 10 years. So we have ROS-based systems and partners with ROS-based systems that have been in production and are still working in the factory floor since 2014, right? So there's a lot of interest if we implement something new, like say around collision detection or a motion planner, that our legacy deployed systems should be able to take advantage of those. In fact, we're heading down next week to roll out some a motion planning enhancement on a kinetic system, right? So we're pretty excited to really put this to the test, and we believe there's a lot of merit in this solution, though there are some trade-offs. So getting into kind of like this idea of the new capability for ROS-II, one of the big things we've been doing is working on our ROS Industrial Training. You may be aware, for those of you who are tightly woven into the ROS Industrial European Union community, they've been doing ROS-II training for a while. We went full ROS-II training last year in 2020 with a lot of different challenges and a lot of feedback. And so we refactored the training and rolled out sort of a rehashed ROS-II training that focuses a little bit more on the fact that, like, hey, sometimes you need to check out stuff in ROS-I, right? But how do we do that in a sort of elegant way? For those of you that have taken both the Americas training and the ROS Industrial European Union training, there may be a small subset of you. They are a little bit different. Our approach is to have folks actually doing some coding. And our goal is we step through and walk through and building it of an application. And then of course in the lab, you've got to build one from scratch. So the goal here then is to, like, even like in certain cases, provide some nodes that are actually ROS-I and then go through that porting portion. Because unfortunately, the state of the nature is, particularly if you're working in the industrial sector, there's going to be some porting very likely. The other thing is to really focus on the bridge. At one time we had the bridge as an advanced topic, but we've brought it forward into the regular training to take a look and make sure people are familiar with it, where best to put it. Like, we used to have this sort of like panel conversation about leveraging the bridge in your ROS-II application. I know there are certain circles that like don't want to hear about the bridge, but in certain situations, it's both needed. We've actually cooked up like 3 variations of an action bridge just for various use cases. So unfortunately, the bridge is sort of a reality as you get into bigger, complex industrial systems, particularly where drivers just aren't existing yet. And that's largely where we're using it. The good news is our labs are now, some of our really nice demos are now fully ROS-II, including the pick and place demo. Again, that's all open source. You can check it down here. Recently, we built out a scan and plan workshop. It was originally expected to be fully ROS-II. We ran into some challenges. It did use the bridge, which was okay, right? Because in the end, like a lot of applications are still using the bridge. It had also its own action bridge as well. So this was a team of about 4 of our developers that put on this workshop. It was led by Levi Armstrong and supported by Dr. Chris Lewis, Josh Langsfeld, and David Mers, with contributions from other team members as well. We hit at one point up to 60 attendees, and it was really, really a good experience. In general, the feedback has been very positive. We used the AWS EC2 experience. We've left it up. Our idea is to turn this workshop into sort of, if you will, an advanced topic as part of our trainings, or a standalone workshop that will go around at different events and put on. One of the ones we're considering is the Automate 2022 show in Detroit, Michigan, where we might like set aside a conference room and do it with our collaborative hardware for those that are interested in potentially attending. This is just basically some screenshots from the workshop. You can see here, we did not do it on a collaborative robot since it went all virtual. We had the opportunity to not worry about the safety aspect of having to go collaborative. So we're like, well, what's the saying? Go big or go home. So we used one of our larger Yaskawa Motoman arms that we have here in our lab, and basically sat out to do some polishing. So here you can see on the left, we're doing some of the tool path planning that we step folks through to generate the raster path planning. And we went through calibration, as well as going through the new Open3D based reconstruction for arbitrary parts. You can see it provides a colorized mesh. So overall, that was a lot of fun. One of the biggest things that we're seeing is basically a lot of ROS-II inquiries for support. A lot of that is around porting services. or evaluations of, like, say something that the end user is familiar with in ROS-I, but they want to see if it works in ROS-II. So that's been a really interesting journey. We get obviously a lot of the questions about should we consider going to ROS-II, and the answer is always a little bit more nuanced, depending on what kind of legacy code base there is, as well as what it is they're seeking to do and what is their time horizon for both going into implementation and then, of course, life after implementation. Always drive that discussion. But one of the big things we've been doing, and we're supporting our membership and just end users in general, is basically testing performance. So there's a lot of questions of like, hey, we need it to perform as such, whatever the metrics are, or is it pick time? Is it motion planning? Like, hey, what is the performance difference between how we did this in ROS-I and ROS-II? The other thing that's actually really emerged as a real popular element is deploying over different OSs. For a long time, when you get into the industrial realm inside the four walls of the factory, there's not a lot of interest by supporting IT organizations and supporting Ubuntu. There's been some movement in this and some contemporary organizations where they're a little bit more open to it, but some of our legacy large end users still have challenges with putting networked Ubuntu boxes on their factory floor. So ROS-II has been seen as an opportunity to deploy on Windows-based hardware. And so we've been supporting some of that and helping partners do that work. The other item that's come up quite a bit is security. So if we are going to network things, how can we ensure some level of security? And I'll touch a little bit more on that later. So there's been some feedback on security, right? And so one of the things that have come on is that there's been some discussions and surveying relative to DDS and the RMWs that came out of the recent down select. So some of you may be familiar, have monitored those conversations about what's going to be the default RMW implementation for Hawksbill. But this drove some other additional conversation. When I went and surveyed, as part of this decision process, when I surveyed the ROS-I community, it was less about, like, say, nuanced performance, latency type data, and more so about, hey, we've gotten sort of the tuning of the RMW to get to a point of expected and anticipated behavior is so onerous that they don't really want to change regardless, right? So if they started with the default, did all of the learning of how the nuances of the QoS, the quality of service settings, setting up security, even if it is only, like, say, a couple lines of code to implement a different RMW, they in the end are starting from scratch when it comes to getting back to that, say, data point of optimal behavior. So the target behavior, or realizing target behavior, is considered to be a real hurdle to prevent people from maybe considering other RMW implementations. So this is sort of some of the feedback that we provided during that down select period. And we've experienced this quite a bit in our deployed systems where, like, hey, we are going to consider a couple different RMW implementations and find the right one that's fit for this application. But typically the let's just say optimization to desired behavior curve is steep enough that we end up having to reach out to the RMW developer to actually get to a point where, without just spinning our own wheels, to get to the point where we get that targeted behavior. So some sort of consistency around tools or other, like a standard, to at least get to some minimal QoS sort of configuration might be beneficial. I'm going to be borrowing here a little bit of content from one of my colleagues, David Anthony. This is actually upcoming, some points that are going to be shared with the ROS-II security working group. They've been doing some interesting work in my partner group next door. And this echoes a little bit some of the preliminary information we're running into from some of our partners as well here in the Americas. And it's basically just, as we sit there and, like, look at deploying ROS-II, and there is a certain expectation of security. Now, granted, it's nice in the notion of most of our DDS tools that we use, that we have the opportunity to leverage the DDS layer for security functions. However, how to incorporate it in your traditional development workflow is not always intuitive. Depending on the complexity of your system, the command line tools, could be a little bit difficult. And obviously verification of configuration is difficult. And of course, obviously, ROS developers are not inherently security experts, right? I think that's probably true for a lot of us here. We lean on colleagues, and I notice, for instance, Alias Robotics is here at the event, and there'll be some other topics on security, but this has definitely been a learning curve for our organizations. You know, in a lot of cases, some feedback from the developers that have been working on it, look for a little bit more, let's just say, tunability when it comes to security. And again, this will all be presented more in gory detail at the ROS-I Security Working Group, but I wanted to highlight it to this community that there is interest in security. But at this point in time, either there's not a ton of resources. Now, maybe you can go to the specific DDS developer, but you know, if we are going to, say, provide RMWs and indicate that ROS-II is ready to go, ideally there's let's just say a certain level of either examples or documentation or some consistency across RMWs to drive a little bit more consistent approach to how we can optimize some of these elements of the implementation, RMW implementation, without necessarily being learned from scratch. So there were some actual feedback provided that may help the security journey. We are sort of struggling with these things as well here on the industrial side. This particular application that David is working on is an autonomous vehicle application, but our experience is the same. The node introspection in particularly would be really interesting for us and really be helpful. And of course, the integration into our CI pipelines as we get a little bit more custom. As you know, for those who've been monitoring the ROS Industrial repos, I think we've got CI almost running on everything. And that's been sort of a journey as we try to continue the quality of contributed software. Let's see if I can get my slide to advance. Whoa. There we go. All right, great. So into the capability stuff, right? Because that's the making robots move is what we're really excited about. So one of the recent things we did is that in the ROS Industrial Americas, we provided over in ROS Industrial a tool set called YAC, which was a tongue-in-cheek acronym for yet another Kinfu. More recently, we ran into issues in certain applications where we started investigating some other alternatives to do our reconstruction. And we came across Intel Labs Open3D. We've got this pipeline now working both in ROS-I and ROS-II. So I encourage you to check it out. There was a presentation. It's out there on the ROS Industrial website on a little bit more of the gory details of how the Open3D reconstruction works. But it basically provides, so to speak, on the fly meshes of your scene, and they are colorized, which offers some advantages. It also offers bundle adjustment, right? So as you're collecting your information, you're always kind of truing up. So it eliminates a lot of anomalies that we got in the prior YAC implementation. The other thing that's really nice and how I personally got involved was imaging the pictures, the part in the bottom right. You know, this is a machined aluminum part. So creating meshes of this with just one shot from perception cameras typically proves very difficult, right? So leveraging these sorts of integrated image capture solutions at the frame rate of the camera really help manage specular reactions and reflectivity that generate a lot of noise and holes in your data. So you can actually get a lot smoother reconstructions of complex parts. Another one that's come up is the Descartes Lite. I know there was also a recent presentation on Descartes Lite, but this one also works ROS-I, ROS-II. So the idea here, it's a ladder graph building library, right? So to basically facilitate Cartesian path planning, right? So that's a really nice, useful tool. It just includes a few of just the core algorithms. It doesn't include some of the other example stuff that was in some of the original Descartes repository. We do have this running in ROS and ROS-II. Nether is also ROS-II compatible. It is for kind of toolpath planning on presented meshes. We have an implementation. I don't think it's actually in the open source repository yet, but we can direct plan on point clouds as well. Stay tuned, and that's also ROS agnostic. Of course, industrial calibration. We did demonstrate this at the ROS World Workshop. I'm going to chase down and see what the status of all the PRs are. It looks like it's still a little bit under development, but we hope to do a nice splashy announcement of when industrial calibration comes out, as well as an offering advanced topic specifically on calibration in ROS-II. And that's intrinsic and extrinsic. So moving forward, yep, we continue to support. As I indicated, we're getting a lot of requests for ROS-II support in the context of either porting or how to proceed in building out new ROS-II applications or testing functionality of ROS-II applications on different OSs. Like I said, right, we will continue to push out repositories that can build ROS-I or ROS-II to help out our legacy friends that are continuing to utilize and support ROS-I on factory floors. And like I said, right, we have new training content we're working in. We'll take advantage of things like the ROS World Workshop to accelerate training content, as well as like take member feedback or feedback from groups and meetings like this, like what is useful, right? What is helpful in the context of training and resources. We're continuously working on documentation, the READMEs. I understand we get that feedback all the time, so please be patient, but obviously offer your feedback. We're always wanting to improve the resources available. Like I said, we'll continue to release additional reference implementations. Basically, there's functional examples, and one of them is this collaborative robotics sanding. You'll note it resides in Suri Robotics. For some of these that are sort of point solutions or specific projects where we were approved to open source them, A5 is somewhat similar. It doesn't really sit in ROS Industrial because it's a specific application, but it is where we can, we want to point those out. If people have questions about how to build a ROS-II application, having one out there is sometimes useful to point at. And obviously, we're looking forward to collaborate with everyone here today. I recognize a lot of the folks presenting. Right, we want to support other resources. So for instance, we're excited to have a Move It maintainer on our team to provide our pick and place demo, which is all ROS-II and Move It 2. That's been a great relationship, and we look forward to continuing that and supporting those resources as well. One thing I did want to highlight was a recent extensibility example. I did mention the A5 program. The A5 program, there's a link here, which hopefully will work in the PDF that's later provided, and if you want to track it down. But basically, it's a human-in-the-loop, semi-autonomous platform that basically can motion plan and do different maintenance tasks on aircraft. In this case, it's working at an Air Force depot. We provide open source to the Americas members due to the nature of the program. It's only in the Americas, the A5 repo. And we had the recent opportunity to take this is what we're doing for sanding on aircraft and some inspection, and do something totally different on a different hardware platform. And this is the video, right? So we had about 6 months to basically port or set A5 up on this FANUC robot with a different omnidirectional base in an interesting painting and defector. And essentially, you notice, for those of you who are familiar with A5, it's basically a big scan and plan implementation. And so in this case, basically, there's a presented part, we do a course scan, pick something out of the course scan, do detailed scanning, which is happening now. There you go. It's even the same sensor, the IFM. And then, of course, do detailed raster path planning to support the process of interest. In this case, it's aerospace painting. You can see there are the tool paths, and of course, eventually it's painting. So I just wanted to highlight that. I mean, we talk about the vision of ROS Industrial as providing foundational modules and building blocks to build new applications. And this is where the rubber really hits the road, right? Taking something that we have out there. A lot of these core repositories are ROS agnostic. Nothing preventing this from being a ROS-II application as well, right? So I just wanted to touch on this recent success story. As always, we have lots of resources, as well as across basically that are global. And right, we always enjoy sharing the success of the things going on in EU as well. And also, I've updated our training link here to include pointing to the FOXI. We have yet to version 2 Galactic. We look forward to updating our training as Hawksbill comes out. That's all I've got.